Now this question seems really, really hard, and if you're not good at math, you might be like totally lost here. However, pretty much anybody at any ability can get this right because you really only need to know two things in order to get it. So the first, and this is the most important, is you need to know what an x-intercept is. Now this is just true throughout the entire SAT. This is a fundamental idea. These are the points where any graph, function, whatever, crosses the x-axis. So you work with these in school all the time. It's maybe not as important as a y-intercept, but you still need to know what they mean when they use that term. Now the rest of it seems very, very confusing. Well, we've got these equations and they're telling us that, kind of different equations are going to have different values, and so we've got to figure out what's going on. And there is a more algebraic, conceptual way to think about this that I will show you, but you don't need it. Because the second thing that we need to know is how to use the calculator. Because this is just an equation. So we've seen this in many parts of the test. We can plug in equations to the calculator and it'll kind of do the math for us. So let's see what happens. Now the first problem we hit is f of x. Now we could make it a y, but I'm not going to do that here. I'm going to keep it as f of x, and you just need to know where that button is. So in the bottom left of my calculator, you see this ABC button. Let's click it, and now we have the ABCs, the alphabet. So we'll do f, we'll go back to the regular numbers, parentheses, x, equals, and then be careful here, make sure you enter it right. So x plus 6 times x plus 5, we got to be careful with those parentheses too, and that's times x plus 1. So there we go. There's our equation. Now, we are not done. There are definitely x-intercepts here, but we don't want to use them because they're going to ask us to do more to this situation. But just to be clear, the x-intercepts are where it crosses the x-axis, and most of the time when you enter an equation into the calculator, you can tap these points. They're special points. If you tap them, you'll see there's an x-intercept at -1, there's an x-intercept at -5, and there's an x-intercept at -6. So if you know where this comes from, that was obvious to you from the start. But the key piece is what happens when we change things, because they're not asking for the x-intercepts of f, they're asking for the x-intercepts of g. So we need to come up with g, and they tell us that g is kind of like this f of x minus 1 thing. So how do we handle that? Well, we just type it in. So let's go to another line, and we're going to go back to our ABCs, and we're going to get g this time, and we're going to get g of x, and we can literally just enter it like they wrote it, equals f of, now we type in x minus 1. And so what it's going to do is it's going to take the f that we already entered, and it's going to do the change that the question is telling us to do, except we don't have to think about it. The computer is just doing it for us. So you can see now we have two lines. We have this red kind of squiggle and now a blue squiggle, and it's the blue one that we care about. So I'm going to turn the red one off. And now we're just focused on the blue. And what they're telling us is there are 3 x-intercepts, this A, B, and C, and the order does not matter, but we want to take those 3 x-intercepts, find the values, and then add them together. So let's see. -5, -4, and 0. So let's add them together. -5 plus -4 plus 0. Well, the 0 doesn't matter, and -5 plus -4 is just -5 minus 4, so that is -9. And that is the answer. So you could get this question, one of the hardest on the test, right? Number 21 out of 22, very difficult question, but you can get it without doing any math. All you have to do is enter the stuff into the calculator and understand the very general concept of an x-intercept. This is why the new test, if you're really clever, you can get a lot of difficult things right just by knowing how to use the calculator. The calculator is a strategy. So how would we get this without knowing that? Well, some of you probably knew just looking at the original f of x graph what your x-intercepts were going to be, okay? We should know that when we have these little factors, those are intimately connected to the concept of an x-intercept. So we can take the factor and kind of like reverse the sign, and we get an x-intercept out of that because we're basically looking for like what turns this factor into a 0, right? So what plus 6 gives me 0? Well, that would be -6. What plus 5 gives me 0? That would be -5 and -1. So those are the x-intercepts of f. And we saw that before. I did say that before. But when we are asked to do this x minus 1 thing, what we need to know is that g of x is going to be the x equation shifted 1 to the right, 1 unit right. And this is something that a lot of people memorize. You probably had a unit on this in school. Personally, I always had difficulty as a kid trying to memorize this. Like, it just, for whatever reason, would not stick in my brain. And so I'm very, very thankful that the calculator is there to just verify it. But if you do have memorized, great. What's going to happen then is like I said, we're going to move it to the right. And we are going to now turn each of those x-intercepts 1 unit greater, right? So the -6, how can I show this? Let's do -6, -5, -1. 1 to the right would be now -5. 1 to the right would be +1, -4. 1 to the right would be +1, 0. And notice those 3 numbers are the 3 numbers we got up here. That's it. Now, maybe that's faster than entering in the calculator, but I always worry about potential mistakes. I have one theory. I don't know if it's going to pan out. But let's say we moved them the other direction, right? Let's say we moved them in the wrong direction to the left, -7, -6, -2. What does that come out to? Well, that would be -15. Yeah, that's choice A. So there you go. Maybe you don't know what's happening here, but the wrong answers in most questions, especially hard questions, are not coincidences. They're not random numbers. They are the things that you would get if you made the most common mistake. So the most common mistake when you're memorizing the way that graphs move, is that we associate -1 with moving to the left. But that's just not how it works. And this is why I, as a student, had so much trouble memorizing this, is that's very counterintuitive to me. But the SAT knows that some people are going to have it memorized wrong. And if they do, they're going to move it the wrong way. And all these x-intercepts are going to go now subtracting 1 instead of adding 1. And if you do the same stuff that you're supposed to do to solve this question, but with the wrong numbers, you're going to get choice A. So you will feel like you did it right. You will feel like you nailed it. Even though it's a hard question and you fell right into the SAT's trap, you won't know because your confidence prevents you from kind of second guessing. And the fact that your answer is there is really, really tempting. And probably at this point, you don't have a lot of time on the clock to even second guess if you wanted to. All of this is to say why the calculator is so powerful. The calculator doesn't make these kinds of mistakes. As long as you enter it the way it's written, you're fine. The calculator will take care of it for you. So this is why, as much as possible, you should shift your solving strategy away from these kind of memorization and algebra-heavy ways of thinking and bring it back towards plugging things into the calculator, plugging numbers into equations, arithmetizing, guessing and checking, all the stuff that makes us minimize algebra and therefore minimize mistakes.